Example 6.3.3. Setup for this one's pretty short. It says a 1-year $1,000 T-bill is priced at $980.39. What yield is it offering? All right, well, if you've watched the two earlier Chapter 6 examples, you probably already know what the answer is. And I chose to use the same cash flows in these examples just so we could see the relationship between these things, between the different aspects of the bond. Let's follow our three-step process. Here, since we do have a time value of money problem, we want to start by mapping the cash flows out. And with bonds, that's kind of where the new knowledge is that we haven't seen yet. That is mapping from the bond description to the actual cash flows. Once we get to the cash flows, bonds are just different types of cash flows that we've already encountered before. They tend to be lump sums or a combination of a lump sum and an annuity if we've got a coupon bond. This one's a zero coupon bond. It says it is a 1-year $1,000 T-bill. That means it has 1 year left to maturity, and it has a face value of $1,000. And for a bond, the face value is what the investor gets paid at maturity. The price is what the investor pays in order to purchase the bond. So if we're looking at this from the investor's perspective, it would be a cash outflow of $980.39. And the question that we want to know is, what is the yield? And yield, we've mentioned before, shorthand for yield to maturity. And yield to maturity has a few different definitions. The one that we used previously was that the yield is the discount rate that equates the present value of the promised future cash flows with the current price. Another definition that is just as accurate, it's just looking at it from a different perspective, is that the yield to maturity is the rate of return the investor would earn if the investor were to buy the bond at the current price and hold it to maturity and reinvest any cash flows received at the same yield to maturity. That's kind of a technical point we'll get to when we get to coupon bonds. In this case, we've got a zero coupon bond, so it doesn't really apply here. The main thing that we are going to use here is that the yield is the rate of return for the investor, and is also the discount rate that equates the current price with the present value of the promised future cash flows. All right, so what type of cash flow do we have here? We've got one cash outflow, time period 0, and one cash inflow at the end of the first year. So we've got a lump sum cash flow, which means we can use the present value or future value of a lump sum formula. We can use the time value money keys on our financial calculator, or we can use the spreadsheet. We will set up the formula here just so we can see what's going on, and then we'll actually solve it using the calculator. No reason you have to do both. I think just seeing the formulas for this one just helps build the intuition for what's going on here. So let's set up the present value, future value equation of a lump sum where the future value is equal to the present value times 1 plus the interest rate raised to the n. We know the future value is 1,000. We know the present value is $980.39. We don't know the interest rate. That's what we're trying to solve for. And we know that there is just one compounding period involved in this one. So if we wanted to use the formula here, we could just solve this for R, right? But I like seeing the setup here because we can see all we're trying to do is find the rate that equates the present value, that equates the current price with what would be the present value of the promised future cash flows. So we're just using this present value, future value, and lump sum formula and finding the rate that equates these two things. Okay? We can do the same thing with the financial calculator. Where n is 1, I over y is what we're looking for. Present value here, because we're going to enter multiple cash flows, we have to be really careful to keep track of the relative direction of the cash flows. So we need to pick a perspective and be consistent with it. I'm going to adopt the perspective of the bond buyer, which means the buyer would have a cash outflow of $980.39. There's no payment on this one. And then the investor would have a cash inflow of $1,000. You could just as easily look at this from the perspective of the bond seller, who would actually have a cash inflow of $980.39. So that would be a positive. When the investor bought the bond, they would receive it. But then they would have to pay the $1,000 to the investor, so it would be a cash outflow. Doesn't matter which way you go in this case, but it is important to tell the calculator that those cash flows are moving in opposite directions. On this one, you'll probably get an error 5 if you don't do that, so you'll know what happened. All right, so let's enter these guys. I'll start by clearing out time value money. N is 1, so I'll press 1 and then N to record it. Skipping over I over Y, because that's what we're solving for. Present value is $980.39. That's a cash outflow from the perspective I've chosen, so I'll make it a negative and then record that on present value. Payment is 0, which it should already be since we zeroed it out, but we'll type it in just in case. And then future value is a positive 1,000. All right, so now we can compute I over Y, and we're going to get, in this case, not exactly 2%, but really close to it, because we rounded this to the penny. And in the first example, when we solved for it, of course, it was worked out to 13 decimal places. If we had reused that answer, we get exactly 2% back. There's a slight rounding error here, but we can just go ahead and call that 2%. All right, so what is that 2%? What does it mean? It means that if the investor were to buy the bond today for $980.39 and then receive $1,000 in 1 year, then his or her rate of return would be 2%. They would have earned 2% on that investment.